So first, some housekeeping before we get going. Apparently, the grand prize drawing for the Windows Code Challenge has been moved from 6 p.m. to 6:30 p.m. If you participated in the Windows Code Challenge and you have a blue raffle ticket, come to the second floor in front of the DJ booth at 6:30. So welcome to our Puppet and Azure talk. My name's Nigel Kirsten. I'm CIO at Puppet Labs, and I'm co-presenting here with Sinesha Foss, Senior PM at Microsoft OpenTech. So some of you may have heard Puppet Labs in the keynote this morning. Our CEO, Luke Kanies, was up on stage showing off some of the Azure integrations that we're going to be diving into much more detail today. We've been around for a while, about 8-9 years now, and we've really been an industry leader as far as IT automation and configuration management goes. We're responsible for curating a bunch of open source projects, including Puppet, and we sell a commercial distribution of those projects that we call Puppet Enterprise. We have tens of millions of nodes around the world, and tens and tens of thousands in some of the largest deployments. But we're also used a lot with people who have 5 nodes, 10 nodes. As you'll see, the benefits of config management scale all the way from the most basic needs for disaster recovery for a single machine, all the way up to really, really large deployments.
Well, hello everyone, I'm Sinesha Foss. Thank you, Nigel. And I work for MS OpenTech. MS OpenTech is a wholly owned subsidiary of Microsoft. And as the title suggests, everything we do is open. We believe that code talks, so do check us out on Codeplex and GitHub. All of our projects are up there. Essentially, as Nigel pointed out today, in the keynote, you looked at Puppet Enterprise integration with Microsoft Azure. And that's what OpenTech is about. It's about building bridges between non-Microsoft and Microsoft technologies. And today, we're here to show you what this open innovation partnership is going to enable you to do in the cloud.
Thank you, Sinesha. So I think a good way of looking at this is that together we're providing a whole bunch more agility. And we're going to sort of cover this in more detail of exactly why this is important. But if you look at Microsoft, have a really rich cloud ecosystem. They've got a very strong developer tool chain. And we've always been really strong in sort of text-based configuration and IT automation. And those two things working together, letting to use Microsoft developer tools as well as Microsoft cloud services, really mean that you're having a much more agile, fluid sort of experience where you can create configuration state, you can test it really, really quickly, and you can push it out to production. So you're going to see, as we go through a lot of this, that we're really about reducing the feedback cycle. So that it's much faster to create change, test it, and push it to production. So when it comes to config management, when I'm talking about Puppet, really, it's about being able to define the state that you want your infrastructure to be in. You're not telling it how you want it to get there, and we'll see some of these examples when Sinesha shows the Visual Studio integration, but you tell Puppet the state that you want something to be in. You're not telling it how to get there. You're not saying how to install a given package, because Puppet knows how to do that. You're just saying you want a given package installed, so it knows what the difference is between an MSI on Windows and how to install it, and a deb or an RPM on a Linux box. So we can create abstractions from these really base units. So we start at like files, users, groups, services, registry entries, file system ACLs, Windows components, and you can build these things up into a single abstraction for, say, managing Apache installation. And then we can take that abstraction and we can compose it at an even higher level. So we could have, say, a whole LAMP stack that's like your Apache, your MySQL, say, PHP installation, and then you can bundle all of that together in a single abstraction, with a couple of easy-to-configure parameters that let you push that out into slightly different environments. And then once you've got this configuration, automating it becomes really, really simple because the workload becomes portable. Puppet really doesn't care where you're installed. It doesn't care whether it's on bare metal, whether it's on cloud, whether it's private cloud, virtualization. It really doesn't matter, which is why this partnership's working out so nicely because we have such strong provisioning on the Microsoft side, and we can move these workloads around really, really easily, as you'll see, from the desktop all the way up to the cloud. So now we're going to show how it actually works.
Okay, so first off, the developer workflow. What we have today for you, and we're also announcing, is Visual Studio plugin for Puppet. And what this enables is creating and editing your Puppet manifests in Visual Studio. So if you go to the Visual Studio gallery, this plugin was published this morning. All you need to do is download and install it, switch to Visual Studio, I'm going to pull down the Tools menu, show you where the extension is. And right here is my Puppet plugin, pre-installed. That's great. Now, how does this work? Well, File New Project is going to bring up a new category under Templates, Puppet Labs. And all you have to do is give it your custom name. So I'm going to call it My First Module. Same workflow, same directory structure. And over here, what we ask for is your account credentials, because later in this demo, you'll see what we're going to do. The Puppet Forge is a community repository that you can actually publish your modules to. And it has thousands of modules that you can pick from today without having to create it yourself. So out here, we ask you to set your module name, the version that you'd like to actually create it as, and you just go. So the first thing that you see pop up is sample code, and this is actually helping configure registry settings on a Windows machine. Additionally, you'll notice on the right that in the Solution Explorer, you can browse through what is going to be the structure of your module. If I did nothing to this module and turned around and saved this locally or published it to the Forge, this would automatically compress archive and upload to the Forge. But let's go through and see what this code actually does. And since we have an expert here, Nigel.
Thank you. So what we're looking at here is a simple couple of Puppet resources. And our resource is the terminology for a single element that you're configuring. So the first one we're looking at is a registry. They're actually both registry services. And this should be reasonably readable for those of you who've had any familiarity with the registry. You can see the Puppet isn't actually a particularly complex programming language to pick up. We're just defining the state that we want things to be in. So for example, thank you, we're setting what the display name is, the description, the command, and whether it's disabled or not. And you can see this is all about defining the state you want something to be in. This isn't procedural scripting like you might be doing with PowerShell or with Bash. This is saying, this is the state that I want something to be in. And the great thing about Puppet is, if that state, the desired state, already matches the current state, it won't actually do anything. It's a pretty lazy tool. It'll only change things if it actually has to, which means that your reports about continuous remediation of configuration really just show what actually changed. You're not having to execute a big, long script and see all of the different results if all of that code was unnecessary. And the reality is most people find it difficult in scripting languages to program things this way. So it's much, much simpler to be able to create, this is just the state I want something to be in. And here we've taken those two resources and we've put them into a class called Registry Service Example. And a class in Puppet is really just a bucket to put resources into and allows you to create those higher level abstractions I was talking about. So for example, earlier when I was talking about the Apache and the LAMP stack, we might have an Apache class with all of the things that are required to run Apache, the package, the config file, the running service, any users that need to be created on the local machine. And then that class becomes an entity that we can just ship around and use to compose other workflows.
So the next thing that you want to do after you finish writing your manifests and your tests is actually package up your module and save it. So I'm going to go ahead and actually publish the Forge to show you how simple this is. And that's it. And off it goes to the Forge. So while that's uploading, let's actually go to the Forge, and it completed successfully. Woohoo. So here's the Puppet Forge, and you'll see some of the Windows modules that are featured for build. And in addition to that, if I actually look for my first, what did I call it? Module. There you go, published under my user credentials in my Forge account. And if you notice, there are 2,000 and odd modules up here that you can actually pick from, try out on both Windows and Linux machines.
So why does this matter? The problem we kind of have in a lot of enterprise IT that most people seem to be suffering from is that, honestly, you can't make change fast enough, and when you do make change, it's unreliable. It ends up breaking infrastructure. And a lot of this is just due to inconsistencies in environments. But if you're using a configuration management tool like Puppet, you're building up consistent definitions of the state that your infrastructure should be in. And you can push change much, much more quickly. The other advantage we have is that because we're using more of a developer-oriented workflow, we've got simple text that we're checking in, we can treat it just like software. You can integrate it into your software management lifecycle, you can version it, you can tag it, you can roll back to previous configurations, you can go through an actual release process with tests. No longer you're relying upon one person filing a ticket, writing a bunch of pros, someone else working out how to decode that, saying they've done it, then the developer going back and working out whether they can verify it. We just don't have to do things that way. We can treat our infrastructure much more like reliable Lego blocks. And the reality is that with the easy consumption of cloud services and software as a service, your users are going to end up going out there and using those things if you can't respond quickly enough to what they want. We get shadow IT when, as an IT organization, we can't fill the needs of the business. So what are we going to be going through today? You've seen the really quick demo showing you how Visual Studio is integrated with Puppet and how we can edit Puppet code. We've got really nice syntax highlighting. We can integrate that into whatever version control system you're already running. But there's more to infrastructure changes than this. And you'll see that a lot of these demos that we're going through today and the functionality we've built is really about reducing the feedback cycle. It's just too slow to stand up a machine in production, make some manual changes, verify that you did it according to the documentation, make some changes, update the documentation. The great thing about using a tool like Puppet is that you're essentially documenting your infrastructure and how it works. So you're going to see what we're going through is that we're going to be using Vagrant, which is a really great tool if you haven't seen it yet, and Sinesh will be explaining how it works, to make changes locally and create VMs really, really quickly with Hyper-V on your local machine that you can push out Puppet configurations to. And you can verify that those are working the way you expect. You can have a really rapid turnaround development cycle. And then we can start provisioning those things out to the cloud using the same tool chain and ultimately end up at something that is a real production service. But again, all with a really, really fast feedback loop.
So, quick show of hands. How many folks have actually tried out testing locally on your workstation with different types of tools, or if anyone has used Vagrant? Okay, perfect. So we've got another new announcement today. For the first time, we're actually introducing an eval Windows box for Vagrant. So let me walk you through what Vagrant is, and we'll show you how it works. So Vagrant is about lightweight, reproducible environments that you can quickly spin up, test out your application stack, and then tear down. You don't have to go to the cloud, you don't have to set up a server, you don't have to set up other machines. Happens on your local dev box, right? So we showed you the Puppet manifest that you created in Visual Studio. Now, how do you test that before you actually deploy it? Before I upload it to the server, I want to be able to spin up a VM, run that manifest there without having to set up a Puppet master, without having to do anything else. Just test that manifest locally, and you're good to go. So let's walk through that workflow. So Vagrant 1.5, which released about a month plus ago and higher, since there have been a lot more releases since then, supports Hyper-V out of the box. What this means is, given a box, or what a Vagrant box is an image that Vagrant can consume, understand what the settings for the virtual machine that you want to spin up are, and tell Hyper-V how to spin it up. Given that Vagrant box, Vagrant can actually spin up your environment for you just with Hyper-V enabled on your client Windows 8.1 machine. So let me show you what a Vagrant file looks like. A Vagrant file is a simple configuration script that you use along with Vagrant commands to actually spin this up. So every Vagrant file always has a Vagrant box. This is what I've called mine. In this case, I am telling Vagrant I want to spin up a Windows machine. And then I can go ahead and configure shared folders, in which case I can share files, my application files that are on my host machine, with this guest that I'm now spinning up. So I don't have to worry about where did I build my application out to, what other files do I need to install anything else on that machine. I can simply drop all the files that I need to run my stack into an SMB share that's created on the host, and then it shows up on your guest. And then the last but not least, you can also go ahead and add custom configuration to test out your manifest. So I have a simple manifest that I put in my manifest folder, and all it does is drop a file on my guest, and we'll open it up and see what it says. So the command to run to actually launch Vagrant is just Vagrant up. In this case, I'm going to use Hyper-V, and so you provide a switch to indicate to Vagrant which provider to use. I've already booted up the machine in the interest of time, and if you switch to your Hyper-V manager, you'll see that it's up and running. So now it's asking me for a username. Essentially, this is so the guest and the host, the guest can authenticate with the SMB share that sets up on the host. So while this goes through, and as you can see, the SMB share gets set up, and it's now running the provisioner, picking up my manifest, executing the script in the guest. And what's happening behind the scenes over here is the Puppet agent that's installed in this box simply applies this manifest to see if it actually goes through and reports back to the host to say, I'm done.
This is where we hope we sufficiently sacrifice to the demo gods.
And it's deciding to take some time. So while that's going through, I'd also like to show you another plugin called Vagrant Azure. So with Vagrant, there are a number of plugins that you can actually install. And if you go to the Vagrant plugin wiki, you will see multiple providers, multiple provisioners, and you can pick up the Vagrant Azure plugin, the Vagrant Windows Hyper-V plugin, which supports Windows Guest for Hyper-V hosts. And with Vagrant Azure, all you have to do after installing the plugin is exactly the same set of commands that you ran locally. So now not only can you test your Puppet manifest locally, you can also test it out in pre-prod up in the cloud before you take it to production, before you upload it to your Puppet master. So while this still completes, I'm going to go ahead and show you that I have created this machine up in Azure. And your Vagrant file for Vagrant Azure looks exactly like a Hyper-V machine, what you did for Hyper-V, that is, except that you're going to provide a whole bunch of additional configurations to tell Vagrant, hey, this is a different endpoint. I want you to use this VM name, login information, what your cloud service is going to look like, what your endpoints should be, and enable WinRM. You can also specify SSH configuration and add in similar custom Puppet provisioning. In this case, I've pre-provisioned my VM in Azure. And I ran an extra command here called Vagrant RDP. So not only can you do SSH, we've added a new command for Windows machines where you can RDP directly into the machine as well. Okay, perfect. So that works. You can RDP directly into the machine, but this is great. I haven't actually done anything over here. I haven't provisioned this machine with Puppet. So how do I do that once I've actually started up my machine? Well, I just run a command called Vagrant provision. What this does is it reads your Vagrant file, which is your configuration that we just talked through, looks at your manifest path, picks up the manifest that is in that location, and then runs it against that VM that you've already created. This is the manifest that I'm going to run, and it's actually going to set some keys in the registry. Really simple. And well, that's off to the races. You'll notice that locally on Hyper-V, we've actually finished up as well. So let's RDP into that box. And if you remember, we were just writing a file onto the desktop over here. Okay. Maybe not today. And here's server, and there's my little file that I wrote out. It says hello world. So what this shows you is, with a few simple commands, with a pre-provisioned box, you can test out your Puppet manifest very simply, locally, or in the cloud. So that's great. I've tested out my manifest. Now I actually need to set up my entire deployment in production. And how do I go about doing that? So this morning, in the keynote, we showed you how to integrate, or how Puppet Enterprise is integrated into the gallery. So if you went to new VM create, now you see a Puppet Labs section under images. You can simply click on Puppet Enterprise 3.2.1. And Nigel, do you want to actually create Puppet Enterprise in Azure?
I haven't done this before.
You haven't done this before?
What should I call it?
Your Puppet Master. So
We have a user.
So I'm actually going to walk Nigel through this to see. This is the first time he's ever doing it. Yeah, I'm check that box.
That one?
We're not going to give it an SSH key today.
Really?
Security, it's all about that.
Lowercase, uppercase, number, special character.
Now I know all of Nigel's passwords. He doesn't know that I've secretly installed a script out there. That's the bank account, right?
Absolutely.
Okay. So you want to create a new cloud service. You pick your region. Or you can choose an existing cloud service to deploy into. We'll create a new one this time.
Okay. Does that work?
Yep, that works.
East US?
Sure.
Availability set? Does it matter?
Doesn't matter. You can set extra endpoints over here if you'd like to. You click next. And that's as simple as how it gets.
That was simple enough to surprise me in the middle of the demo, to do something I hadn't actually done before.
So
You can have it back.
So now that we have the Puppet Master, we actually need to install we actually have to bring up our deployment and set up our VMs with agents. And sure, you can provision VMs, but today we announced that you can actually bootstrap agents directly into the box with the provisioning workflow. So again, compute, virtual machine, choose your VM, choose your image from the gallery, choose a Windows box, choose a Linux box. And essentially, we give it a virtual machine name. Let's call it my Puppet client. The usual configuration settings. Pick the same aspects. Apparently, Puppet Client's been created as a cloud service, so we'll pick a different number. And now you'll see on this last page that you can install the VM agent, you can install the Puppet Enterprise agent, and then you can give it a Puppet Master server, so the FQDN of the server. I'm going to give it a pre-created server. There you go. And that's as simple as it gets again.
Nice.
So some of the things that we talked about today, you can actually go to msopentech.com under Projects DevOps, and you can see a whole bunch of tools that we've actually enabled in the space. We'll talk about this a little more after that goes.
So I think one of the really great things about using Vagrant for this sort of workflow is that it essentially automates that whole process of create a VM, create a snapshot, make changes to it, roll back to the snapshot. You'll see that what the demo Sneha was showing was you start off with this basic box, which is a vanilla sort of state. And when you're defining all of the configuration in a tool like Puppet to be applied on top of Vagrant, you know that you can guarantee that there's no breadcrumbs left behind from previous development efforts. There's this really frustrating process you can go through when you're doing things manually, where you create a blank machine, you make a whole bunch of changes to it, and you forget to record one of those for the production change. Or worse, you decide to reset everything, and you only think you reset to a clean state, and there's still some little bits and pieces left around. So that when you actually do go to push to production, nothing actually works properly. And so Vagrant essentially automates that all for you. So you've got the VM, it starts with a vanilla state. The only changes you're making to it are through the Puppet manifests that you've written locally and that are applied. And so if it's working the way you want, you then know that when you push up to Azure for your cloud production, pre-production and production services, that the configuration state in Puppet accurately describes the whole service that you're actually trying to build. So seeing as we've got a reasonably intimate group here, who has come across the term DevOps? Who thinks they know what it means? Okay, no, so this is fair enough. Like, DevOps is one of those terms, it perhaps hasn't been perturbed as much as Agile by the consultancy industry, but it's maybe getting a little bit close. I think the best way to think about DevOps is that it's a loose collection of practices. And really, these practices largely relate to operations, working better with development to deliver applications. It was a term that sort of came out through a lot of the sort of web scale sort of companies and a lot of people who are getting really frustrated with people throwing code over the wall to operations to deploy. I've lost track of the number of companies I've gone and talked to where it turns out operations just never even talk to the development team except via their ticket system, which is not a particularly functional way to work. So I think the best way to think of it is as a loose collection of practices. You can't buy a DevOps in a box. It's not a thing that has a really concrete definition that you can go and purchase from someone and suddenly you're DevOps. And in fact, there's a really big opinion in the community that even having people whose title is DevOps isn't a particularly functional way to be. Really, it's about a better way of doing development and a better way of doing operations. And I can see there's a big cultural sort of signifier if you start renaming your operations teams DevOps teams, that you're really saying you're trying to practice a lot of these principles and practices that have grown up. In one of the really early DevOps Days conferences, it was sort of proposed that the 4 sort of pillars around DevOps really rested on culture, automation, measurement, and sharing. And the reason culture's there is because that silo I mentioned earlier. It's really dysfunctional for people to work in this manner of one team's going to write the code, they're going to huff a tarball over the wall to another team who's going to do QA on it, who's going to then pass it down to operations, and when they go, well, it actually crashes when someone tries to connect to it. You end up traversing back through that whole chain, and it's a really long, slow feedback cycle. And so a lot of it's about coming up with a common language for your development teams and operations teams to work together. And so when you've got a tool like Puppet sitting in your version control repository, one thing that happens that people don't quite realize will happen is that your developers start looking at that code and going, well, I know I'm going to have to change that config file, or I'm going to have to change this setting. And they'll start issuing pull requests and change requests against your Puppet code. And so teams can actually work together with a common language rather than communicating via prose that then needs to be decoded. Puppet's a pretty easy language to pick up for anyone, but particularly for a developer. It's largely a specification language. It looks a lot like you're monitoring on Nagios configuration files. And automation matters a lot here. It sort of removes, the blame game. It removes inconsistencies between pre-production and production. When you've got all of your components for your infrastructure defined in a tool like Puppet, you can have that on a developer's workstation using Vagrant. You can have it in a pre-production environment. Your QA team, your production, you know that all of those systems are actually configured exactly the same way. So you need to automate these processes so that you can move more quickly. Put more automation in. When people make a commit to a certain repository, have it automatically deploy to a pre-production environment. Only leave humans in as the gatekeepers in the bits where it really, really matters. And measurement's a big part of this. Once you've got a usefully automated process that you can actually measure how long it took, measure how frequently you're doing it, you know what your baseline is for improvement. And it's that continuous process of automating things, measuring them, returning and repeating that cycle that really allows you to deliver applications and changes much more quickly and much more reliably. And finally, sharing. This has been, it sounds a little bit Sesame Street, I guess, but this has always been a big part of the community. And we're not just talking about sharing out to the world. Not everyone works at a company where they can do that sort of thing, but it's about sharing within your company too. Why have 50 different configurations for a given Java middleware when you don't need to? Why not just have the architects who are actually good at defining that work, write it up in Puppet, create an abstraction around it with a couple of simple parameters for people to modify, and then everyone can deploy it all over the place, and you know you're deploying it on top of a consistent and standard stack. So you see a lot of people use the term DevOps. I really do prefer to think of it as a loose collection of practices rather than something you necessarily look up in the dictionary and get a bullet point list, and once you've finished all of those, then you're DevOps. So where do we sit in this whole process? So we because we're defining our configurations in simple text-based formats that can be checked into version control, that you can do diffs between, that anyone can open up the repository within your company and see what the configurations are actually meant to be. It breaks down a lot of these walls between groups and allows IT automation to actually become a central part of the business rather than just a cost center. You can see that we've developed a whole bunch of different stacks when it comes to Puppet. So we worked with some pretty basic building blocks here. You saw Sinesha create a file, put some text into it. You saw some examples of some basic registry entries. But as you build up more and more reliable components, you're going higher and higher in the stack. So you'll see on the Puppet Forge that we've actually got middleware modules that are rather large and complicated. But someone's actually gone to the trouble of codifying best practice and a reliable way of deploying that middleware, and you can largely just consume it. And if you need to modify it, you know it's something you can easily modify yourself. It's pretty readable, and then you can always push changes back up if you're able to. And you can see that we work all the way up down the stack. Physical and virtual nodes, we don't really care where Puppet runs. Once you're inside the machine and Puppet's collecting facts about the system and applying manifests and catalogs, you'll see that Sinesha was able to push the same kinds of configs from a local machine, virtualized, and up into the cloud. So one of the things I wanted to talk about was the difference between our open source and our commercial projects. So we have a whole bunch of open source projects, and it's always been a big part of Puppet Labs. We have Puppet, we have mCollective, we have a whole bunch of smaller components and things that sort of cluster around the Puppet ecosystem. And those things move at a pretty fast pace. If you're one of those people who honestly has a lot more time than money, it may make sense for you to adopt some of the open source projects. If you're willing to sort of go through the process of dealing with upgrades and staying on sort of more of the bleeding edge. But we also provide a more certified version of Puppet called Puppet Enterprise. And you can think of this in many ways as analogous to the difference between Linux and Red Hat. There's a Linux kernel that gets lots and lots of releases all of the time, but Red Hat go through a process of certifying it, making sure that all the components, all the different projects they have actually all work really well together. And that's what we do with Puppet Enterprise. So this is the one that we've kind of burnt in. We've seen it tested out there in the real world. We've got a big, huge sort of user community out there essentially doing QA. And we take all of those open source projects that we curate, and plus a bunch of other things, and give you all of the dependencies on a single stack. So when you install Puppet Enterprise, you don't have to care about what version of Ruby is required, because Puppet uses Ruby as an extension language, which version of the JVM gets installed, because we run some of our high performance code on the JVM. We kind of package all of that up together so it's a single entity, so that you can upgrade from one version of Puppet Enterprise to the other confidently. And one of the things we talked about earlier was the Puppet Forge. So forge.puppetlabs.com, you see, I think on the front page right now, we have a whole bunch of highlight modules for various Windows-related things to do with the Microsoft Build conference. And you'll see people have been committing all sorts of things there. We have thousands of modules that people are using to do real work. So when you want to get started with Puppet, you're not building everything from scratch. There's this kind of general principle that people tend to treat their infrastructure as special snowflakes. But the reality is most of what you do is exactly the same as what everyone else does. 80% of your infrastructure should probably be configured the same way as the rest of the world. because this isn't rocket science. We're not inventing new things a lot of the time. But there's that 10, 20% of infrastructure that is special to you. So you should really focus on taking that 80%, automating it according to best practices, grabbing content from the Forge, deploying it, and then spend your time focusing on that 10, 20% of work that really is special to your organization. But honestly, how many different ways are there to deploy a JVM? There's lots of wrong ways, but there's only a few really right ways to kind of do it. You can configure specific Java processes in specific ways, but you don't need to go reinventing this all yourself. There's this other saying that people use a lot, which is, treat your infrastructure like cattle, not like pets. Your servers aren't special. You should be able to just blow them away at any time and restore your configuration state onto them. There's no need to give them special names and treat them specially and special care and feeding. They're machines. You'll also see that we've just been mainly demoing stuff on compute nodes at the moment. But Puppet actually is a pretty portable framework. We actually started off largely in the Linux space, but a couple of years ago made a really big push into Windows, and it turned out that the model in Puppet is really, really portable, and it's working really, really well on Windows. We've been really enjoying Windows as a platform. We're getting huge demand for it. And we're also moving into the network and storage space. So the same Puppet code that you're writing to manage your compute devices, manage services, you can also run on like Juniper switches, on Cisco switches, and a whole bunch of other devices around the world. So you can manage your firewall rules, your VLANs, your interfaces. You can manage your storage configuration. And once you can do this, this again helps you break down silos. You don't need to go through that whole process of network operations, getting a ticket from IT operations who got the ticket from developers to open up a port in the firewall. You can get people to agree on configurations across compute, network, and storage, and then they become portable chunks of infrastructure that describe more than just compute. And you can move them around in different environments and have all of the network and storage configuration follow them just as well.
Thanks, Nigel. So one of the things I wanted to talk about is, today we showed you Puppet, creating Puppet in Visual Studio. We showed you how you can test it out locally. We showed you how you could test it out in the cloud. We showed you how you could launch Puppet Enterprise Master in the cloud. And what you'll see is essentially there's this starting from your dev box on up to the cloud, different sets of tools that are coming together. And that's the end-to-end tooling that we're working on in OpenTech with partners like Puppet and also with Microsoft. And so what I have here is a few other options, a few other partners that we're working with to bring you further tooling, which is not just deploy in the cloud, but how do you configure, manage, and also monitor in the cloud. So going back to the site I was showing you earlier, we have a collection of plugins that we have listed on our OpenTech DevOps subsite. And you will find all of the plugins that we've released so far up here. So we've got a number of additional plugins that we're not going to talk through today. So please do go ahead and check it out. And we also have Nagios and Zabbix plugins as well that have been published. Sorry. I apologize. Could you switch back? I wanted to also show the Puppet console, which we kind of skipped over.
Oh, cool. Yes, we did.
Yeah.
So this is the front page of the Puppet Enterprise console. And really what this does is it gives you a snapshot into the state of your infrastructure. Well, it was the Puppet Enterprise console.
I had
It's okay. So you can see here, we can see the state of our infrastructure. That panel on the left-hand top left really shows you how many nodes are currently unresponsive, whether you've had any changes made. So one of the things I didn't really go into is that Puppet by default runs every 30 minutes. And so it actually helps you remediate configuration drift as well. The reality is sometimes machines change a few things on their own, a package installs, changes some settings that you didn't actually want to be changed, but Puppet running every 30 minutes will make sure that the current state of the machine is the desired state. And so that blue line there is when you push out a change, you can actually be confident and say, did that change actually reach all of the machines it was actually meant to? We can see machines that are unchanged, where Puppet's running and going, nope, everything's currently right, and I don't actually need to do anything. And so we see our machines down here. If we were managing network switches, they'd appear in exactly the same spot. So when you've got the Puppet Enterprise agent running on compute or network, it all appears in one pane. And we can drill into them to have a look at different things. So if we have a look at reports along the top there, we'll see these are all the reports of the nodes. So those exclamation marks mean that we had an error at some point. I guess as we were putting together the demo, we might have had some bugs in our Puppet code. They may have failed a syntax check. And we see really clearly, so as we push to a test environment or a pre-production environment, whether it's actually going to work or not. We can see all of the failed machines. And there's a whole bunch of other things in the Puppet Enterprise console. You can actually download an evaluation copy of Puppet Enterprise and manage up to 10 nodes for free. So I highly encourage you all to go and grab that. We also offer a learning VM, which you can download a pre-packaged VM and run through a few tutorials to get your feet wet with Puppet.
So what this means for you, essentially, is we're leveling up the tools that we're bringing out. And so your favorite tools, open source or otherwise, you're going to start seeing line up and help you create, manage, and deploy your applications in the cloud. So we have a few resources for you, additionally over here. You can find additional documentation for today's announcements on the OpenText site, on Azure, on puppetlabs.com.
Mm-hmm.
And please do fill out our feedback. So any questions?
If you could go to the mics would be most useful. Thank you.
Hypothetically, if we had nodes on different cloud providers, is there any consideration we'd have to do for the Puppet scripts?
No, so there's a few little things. So Puppet has a concept of facts. So when the Puppet agent first runs, it collects a bunch of facts about the machine that you can then use in your manifest. So that could be the operating system, the version the version of the OS, what the uptime is, network interfaces. And there's a few extra facts that will appear, like when you're on Azure, a few extra facts will appear about the metadata that's available there. And metadata is slightly different across cloud services, but that would be about the biggest consideration. So if you're writing your Puppet manifest so you weren't actually making use of any cloud-specific metadata, it'd be totally portable. If you were taking advantage of some of that cloud metadata, it'd just be some pretty minor changes. Puppet workloads are generally really portable. Any more questions? I can repeat the question if you're stuck in the middle of people.
So, practically speaking, how does Puppet help me do either continuous integration from my source control environments or mass pushes of software updates or configuration updates? Because that's impossible, right?
Okay. So the question was, how does Puppet actually help you manage your CI pipeline and what you're actually pushing through it? And how does it help you manage pushing out lots and lots of software updates? So one of the really great things is once you've actually defined this in code and you're saying, I need this particular MSI installed on all of these machines, you can basically, you might have a group in the Puppet Enterprise console that's your base group for all of your nodes, or say the subset that you're just targeting. And you can push that change through. You can test it on a small canary group of nodes. We have a concept in Puppet called environments that lets you sort of divide up pre-production from production. You can push that out, check that it's actually working on all of those, and then it's literally, you promote that to production, and the next time all of those agents check into the master, they'll push out that package. So it's really, pushing out software packages is really sort of bread and butter for Puppet. As far as the CI pipeline goes, there's sort of a few things there. One is that having a consistent building block of all your infrastructure, so that you actually know that all of these machines are set up the right way, suddenly it becomes really practical in your CI system to trigger creating a VM, creating a new instance in Azure, and then pushing that configuration to it, testing it, and even perhaps doing your smoke testing and sort of black box testing there as well. And you can have all of these sort of automated gates, because once you've defined the state, and that's actually the thing that you're pushing around, it becomes trivial to tell computers to do things to other computers and then read the results. Did that get to your question? Okay. Anyone else? Sure.
So you mentioned, so you talked about files and you talked about registry and things like that, but you didn't necessarily talk about all the different providers that are supported under Windows as far as things I can configure and deploy, like potentially SQL Server or App Fabric or those kind of things. I mean, are there special providers that I need to be able to install an App Fabric and configure it via Puppet, or is that, how does that kind of come
Yeah, so we'll jump back to the Forge. Let's go to the front page and have a look at some of the Windows highlight ones. So you can see here, how many of you know about Chocolatey, by the way? I'm kind of curious. Oh, cool. So one of our lead developers on Puppet Windows team is actually Rob, who started the Chocolatey project. And so we've got lots of really great Chocolatey providers. So you can actually start to treat Windows as if it had a package repository for third-party software. So that becomes really, really easy and really, really powerful. And I think we're going to be working a lot more with Microsoft in the Chocolatey direction.
Right.
But yeah, we can manage IIS components here. What else have we got here sitting at the moment? Windows environment variables. So basically anything you can programmatically query or set is really, really easy to build in Puppet. So were they the sort of things you were looking for?
Yeah, so you interface with PowerShell, so like some of the Microsoft, right?
Yeah, so we can actually push out chunks of PowerShell code. We can push out chunks of pretty much any scripting language on different platforms, but there's a really nice PowerShell provider that lets you go execute this PowerShell script. So that's a really great way to get started too. My general advice for people getting started with automating their infrastructure with Puppet is pick something pretty small and automate it across all of your infrastructure. Don't pick one complex service. Try and model the whole thing and don't move on until you're done. Pick something simple that's causing you a bunch of pain. Maybe it's setting Windows environment variables. Maybe it's running some of your PowerShell scripts that you have sitting on a share somewhere. Pull those into Puppet, grab some of those scripts, and just have Puppet become in charge of actually running them regularly. And then it becomes easier to incrementally improve the amount that you've automated in your infrastructure.
So is the automated installation of Puppet and those Windows VMs in Azure, is that unique to Azure? I guess because we use VMware at my company. So I know it'd be cool if I could just have the automatic installation in Puppet and configure it to connect to the Puppet master.
So if you look at the recent version of Puppet Enterprise, there's a pretty low friction way. I can't promise it's as easy as sort of clicking at 2 buttons in Azure. But you can always, what people often do is they'll build their vanilla OS templates in VMware or something, and then they'll just install the Puppet Enterprise agent onto it and make that sort of their base load. We can do a few things like we can embed tokens in base images so that when that machine first boots up, it knows it's from an authorized image that automatically goes through the process of accepting a new Puppet node. We didn't actually show you this, but Puppet, all of the communication between the master and the agents is just SSL HTTP, and there's SSL client and server certificates authorizing everything. We've got a few things to help that provisioning step. But honestly, I think the sort of really easy integration with Azure is about the simplest Puppet Enterprise deployment I've seen. You're not allowed to leave until the hour, so you should come up with some questions.
Actually, on a somewhat related question, the automated PowerShell scripts for deploying VM instances, have you extended those to add options or parameters for installing Puppet?
Are there PowerShell scripts for Azure images?
Yeah, so basically you can actually go out for a PowerShell command connecting through the Azure instance and actually provide it a parameter set, including what agents do you want to install?
We actually do have commandlets for Azure, and you can find them up on GitHub as well, but I'm just going to do a quick search.
Have they already been extended to include this particular change to VM
To VM provision with the Puppet agent? Yes. So you can actually set on your VM object the Puppet, you can set the Puppet agent, and then you can say you can run new Azure VM, and that'll provision and bootstrap the VM, bootstrap the agent into the VM for you.
So just out of curiosity, though, are you using the PowerShell provisioning scripts already to sort of have more of an automated pipeline? And you just want to be able to essentially use Puppet functionality on top.
I'm going to switch out. So we did publish the new Azure just dropped a new PowerShell update, And so if you pick up the new module, you'll see these new command lists that come up.
So they're actually out for session include as well. Hosted include. I can't remember. I'll talk to you about it.
Okay, so the question will be repeated later, perhaps. So you can install and uninstall these agents.
Tell me.
All right.
Switch back. This one?
So if you go to Azure SDK Tools, you'll see all of our PowerShell work up there too. And you can download and install the latest module, which will show you the list of
How many
New
other people are
commands on
doing
the
automatic Azure provisioning via scripts or something? How many people are doing it by hand? Semi-automatic? Yeah.
Okay.
Cool. So if there's no more questions?
You mentioned provisioning, agents and stuff like that, but you didn't talk about potentially orchestration, of how, if I've got 3 or 4 nodes, I may not want to apply the configuration on them all at the same time. I may want to only take one and apply the change to one, while the other ones are still operating. You didn't really talk about orchestration and how I might make that happen.
Yeah, so we've got an orchestration tool called mCollective that uses a message bus to sort of communicate with all of the nodes in your deployment. And you can slice and dice and pick specific nodes to say, I want you to do something now. So the process people would often go through at scale, because the question was about how do I canary changes on a couple of machines before pushing it out to everyone? People tend to take one of 2 approaches. They either use Puppet environments to create big sort of separation. So it's like these 20 nodes are always going to be a test environment, and the other 10,000 are going to be production. And so you'll promote those changes up through, say, version control branches. So if you were using Git, it might be like a different branch between test and production. The other way is you can use mCollective to say, I actually want to disable Puppet running right now because I'm going through a change window, and I'm going to re-enable it selectively on a couple of hosts, and I want you all to run Puppet and tell me whether it worked or not.
Yeah, but not just canary changes on the environment, it's also, keep my 100% uptime across the clusters. So if I need to apply something to one cluster, I might fail everything over to these clusters, apply my changes, push everything back over here, and apply my changes here.
Yep. So the question was more about coordinating backends of clusters so that we're making sure that the service is available all of the time. So the way people would often do that is they'd create a couple of facts on those machines to say, I'm a member of this cluster, and I might maybe assign people IDs throughout the cluster. And you could do things like go, I want to address the whole backend pool for this given cluster, and I want to apply this change to half of you, or I want to apply it to 1. So you can sort of do that fine-grained control with mCollective. It's a little less GUI driven than some of this. If you went through the GUI, it'd be a bit more of a manual process of going, disable Puppet running on all of these hosts, and then re-enable it on these ones that I've selected. Yep. So you could do things like that, the way you'd say, give little attributes to the nodes so that you could work out a way of addressing a subset of them really easily. Okay. Thank you very much.
Thank you, folks.